I will give the teacher the benefit of the doubt on this one. Crewton Ramone's House of Math, fooling around with Adam, or not Adam, Ollie, East Coast crew in effect. They can't see you. You're behind the camera. So we're talking about the difference between distributive, associative, and commutative. And a second ago, he was trying to tell me that his teacher was telling him that 3 plus 2 plus 7, for example.
No, not plus. Like 3 plus 2 times 7.
Okay, see, there you go. See, I told you, there it has to be, because, okay, so if I did 3 times 2 plus 7, there you go, you have to distribute, right?
Yeah.
And that is exactly the same, distribute, as 6 plus 14, which is exactly the same thing. Oops, that's 3. It's 3, so it's 21. What the heck am I doing? Right? 3 times 2 is 6, 3 times 7 is 21, and that will be the same thing as 3 times, oops, 9, which is the same thing as 27. Right?
Yes.
Let's show the distributive property a little bit more with using the blocks and being really simple. Just talking about distributing. Now, you gave me this really long, convoluted answer about what the distributive property is. Distributive property is everybody gets multiplied by everybody else. Right?
Yay!
Okay. Right. How old are you again?
11.
11. There you go. Okay. X plus, see, you're totally ready. No longer impressive. When you were 5, this was impressive, but now you're 11 and it's not so impressive. Actually, I didn't know you when you were 5. I knew you when you were like 7, right? Or 8.
I was like 9 or 8.
Yeah, 8 or 9. I think you just turned 9. I think you were 8 and then you just turned 9. Anyway.
Yeah.
So let's do something easy like x plus 3. Why are people beeping me? Get out of here. I gotta turn that off. Hold on a second.
Oh, you. I thought they updated it.
No, that was me. We'll just shut it. No problem. Okay, you're gone. And that email's gone too. All right, so x plus 3 times x plus, I don't know, 2, just for fun. Okay, so what does that say?
Oh, what?
So what does that say? X plus 2 times x plus 3. You can see it, right?
X plus 3 times x plus 2.
X plus 3. Okay, so x plus 3 means that's my across, that's my up. Now let's demonstrate the distributive property of multiplication. So here I am, x plus 3. I'm going to be fast with the blocks. I'm not going to get out single blocks because this is much faster. And then I'm just going to be x plus 2 up. And I'm going to grab 2 of these because that's faster than finding my 2, which has somehow flown the coop. Oh no, there it is. Boom. All right. And we can talk about partial products and all that fun stuff. What is going on here? Oh, I just cleaned the board with board cleaner, and now it's slippery. Ugh. Ah. Alright.
I do it perfectly.
Alright, so tell me about the partial products here. Because what they're going to do is give you FOIL or all that. Now I'm just going to multiply everybody by everybody else. I'm going to multiply straight across, and I'm going to say, look, I got to multiply x, right? Because this is across. X plus 3 times x plus 2. So when I multiply x times x, x times x, of course I get x squared, right?
Okay.
Do you see it? X times x is x squared. X times x is x squared.
Yep.
Okay. And then what? Then I have to multiply the x times the 2. So here I am, x. So see, you see it in 2 parts here? In fact, we can break it apart here, just to make it easy. X times x, that's that one. And then x times 2, that's that one. This part here. So isn't that just 2x? X times the x times the 2 gives me 2x. Questions?
No.
Okay, so I just counted this one and this one. And what I'm doing is I'm multiplying the x times the x and the x times the 2. Right? Bam.
Yep.
Okay. Because if I wrote it out, I could say that we'll do that in a second, and we'll see it. But do you see that there it is, that I'm across x, and I'm up x plus 2, so of course I get 2x. Alright, anyway, belaboring the point, way past what we need. But some people really need the explanation I found. Alright, so then I gotta multiply the 3 over here. What's 3 times the x plus 2. Well, 3 times the x is what? What? What's 3 times the x?
3 times the x is 3x.
There you go. And what is 3 times 2? That's the real tricky part there.
3 times 2 is 6.
There you go. Done! Now we have counted everything. We have counted both of these rectangles. The x times the x plus 2 one. In fact, I could write this out further. Let's get this out of the way, and I could do this because they were doing this in a school and like it was some tricky thing. That I could say that that's the same thing as x. Let's make some more equal signs. Times x plus 2 plus 3 times x plus 2. Right? Isn't x plus 2 our common factor?
Uh-huh.
And further, I'm really doing some analysis here, but you can point it out to your kids, and they'll get this easily, that I can rewrite this as that and that. But I'll do it yet again. X, right? Squared plus 2x plus 3x plus 6. And again, now what did you say? One of the things they were talking about is what? Combining what?
Is like combining like terms.
We only add stuff that's the same. Concept number 2. So we have any like terms here?
Yeah.
Okay. Right there, right?
Yes.
So the long way about it is x squared plus 5x plus 6, what we finally get. And I can draw a little drawing of it right here. And man, is that faster and easier. And what they're going to do in Common Core pretty soon is they're going to make you do all this crazy stuff instead of just being able to see that, oh, look, you can go from there directly to there. And add the 5x and add the 2x and the 3x in your head to get 5x.
Mm-hmm.
Further, let's make it fun. Now, I stress this to everybody, including you. Remember, this is not a 10. This is an x on the smooth side, right?
Mm-hmm.
But since they're base 10 blocks, let's just substitute for 10 for the fun of it. So now, this is 10 plus 3 and 10 plus 2. Isn't it?
Mm-hmm.
So in your head, couldn't you see, now this is, right, I've got the same thing, they're not colored, they're in black and white, but you can still visualize that that's 100. Oops, that's a 10.
I thought you said 10. Okay, yeah.
Yep, 10.
So that would be like
10 times 10, and that would be the same thing as 13 times 12. Correctamundo.
Yeah. Yeah.
Yeah, baby. All right, let's move back a little bit. Okay, so we can see everything. Because here it is in expanded notation, there it is there. So then this would not be 2x anymore, this would be 20. This would be 30. That would be 6. And I can certainly say that that's the same thing as 10 times 12 plus, whoops, I actually left the plus, times 3 times 12. And certainly I could do it again all the way over here and do that exact same thing, but this time I'm not going to. And I could just say, look, it's 156. This is why you and other boys look like geniuses, because you can do it in your head because you've been doing it for years now. And look, there it is, all combined together. Right? No expanded notation. We stuck those two together. We put that, right? 156. Distributive theory of multiplication. Okay, what else are you doing? All right, so anyway, there is a explanation of the distributive theory of multiplication. Adding like terms, right? Because here we had the 20 and the 30 to get the 50. Putting the blocks together. They used to do it in expanded notation all the time. But expanded notation has left a lot of textbooks, and now they're bringing it back again because the kids need number sense. Okay. Crewton Ramone's houseofmath.com. Wait, let's put you in the picture just so people can see who the kid was that we were playing with. There is. There he is. Yay. All right. Crewton Ramone's houseofmath.com for more.